Unit 6C, Software Security. Malware. What happens when good software goes bad? Malware. Malware is any software that intentionally violates your security policy, either your written policy or your implicit policy. Malware can violate this policy by doing things like sniffing network traffic to look for credit card numbers, then forward these numbers to an attacker, inducing users to enter their user ID and passwords into a malicious site, allowing an attacker to control your computer to commit massive mayhem, a distributed denial of service attack perhaps, pulls sensitive files from your company's servers and ships them to a file sharing site, and more. Malware types. The main type of malware is a virus. It's a delivery mechanism for malicious content. A virus requires something else to execute and propagate, meaning a virus is not a standalone application. Stealth viruses try to hide the changes they make. The ones that make more sophisticated and more thorough changes can be called rootkits. A script or macro virus is written in an interpreted language like VBScript or JavaScript. A polymorphic virus varies itself or mutates as it reproduces to evade antivirus signatures by eternally changing. Self-garbling or encrypted viruses decrypt themselves only to execute. They do this to hide from antivirus. They're called self-garbling because sometimes they don't actually use true encryption. They just use methods of obfuscation. And a multi-part virus has a small portion that infects your system that then communicates out through the internet, kind of phones home and grabs other parts or pieces of software to complete itself. Worms reproduce, but they're entirely self-contained. They don't need additional software other than the operating system to spread. Here they're different from viruses. A Trojan horse is an attractive program that tricks a human being into executing it. It hides a deceptive, malicious payload, and a Trojan horse, because they're made of wood, does not reproduce. Spyware and adware gathers information, personal information for marketing purposes, usually, without being forthcoming about it. Oftentimes this stuff is just marginally legal. It hides behind a long, obscure end-user license agreement, or EULA. A logic bomb is something that senses an effect that causes some malicious software to suddenly execute. For example, termination of a programmer might be sensed, and all hard drives are then erased. A logic bomb is often an act of revenge planted by an insider who knows what's coming. Botnets are small software agents under the control of a central authority, the command and control network. They leverage controls over many systems for large-scale mayhem, like delivering large volumes of spam, undesirable commercial email, denial of service attacks, etc. Large botnets can have millions of agents. There are actually markets out there for botnets. People own these large networks and rent them out, and there are underground websites where folks actually transact to do this sort of stuff. Rootkits allow an attacker continued access to a system. What they do is they conceal the fact that the rootkit is on the system from a user or system administrator. If you use your commands to look at the file system, look at running processes, etc., you'll see nothing out of the ordinary because the rootkit conceals its own existence from you. There's two types of rootkits, a user level and a kernel level. The user level just modifies the commands to cover up the back door. Things like in Unix, the ls command to list files. It will replace that with a modified version that will conveniently skip over any files created by the rootkit. Whereas a kernel level actually goes down to the operating system kernel and covers up the attacker presence that way. So any legitimate tool that hooks into a kernel application programming interface or API will get incorrect information that conceals the fact that you've got malware in your system. Rootkits are very, very nasty things, and generally when you get one, the best advice is just to re-image the system. Here's an illustration of how malware types work in terms of rootkits. Kernel level rootkits operate by compromising either the operating system directly or in some cases by installing a malicious device driver. Device drivers, like the operating system, talk directly to hardware. So a bad device driver, particularly one governing your keyboard, your mouse, your monitor, etc., can do a lot of damage here. Whereas user-level rootkits will either replace application software or commands that the operating system shell uses. How to fight malware. Antivirus software can be used to fight malware. It's based on code patterns specific to the malware. Novel or changing, meaning polymorphic malware, can defeat antivirus. It tends to involve pattern matching. Some types of antivirus claim to have more sophisticated methods of determining patterns, heuristic antivirus pattern matching, etc. But ultimately it just boils down to, is there something here that matches a pattern of something bad? Intrusion detection systems, intrusion prevention systems are typically network monitors that look at the traffic going over your network, and what they may find is something that matches a pattern associated with malware. The thing with malware writers is, whereas the code itself is often well hardened to prevent antivirus software from attacking it, the messaging that the malware uses to phone home, get back to the command and control center if it's a botnet, etc., is oftentimes fairly easy to uncover, and a good intrusion detection system will often find malicious software where an antivirus won't. There's also tools specifically designed to detect rootkits, saying, is there something wrong with the operating system? If we ask the operating system the same question in two different ways, do we get slightly different answers? Well, if you get different answers, then there may be something tampering with the operating system. And then there's file integrity checks. Has some sort of critical file change without warning? For example, has an operating system file on disk changed suddenly without any good reason? A good file integrity checker will tell you that. And an example of that is a product called Tripwire, which used to be free but is now a commercial product that tells whether files have changed based on kind of an outside audit. And that's it.